everyone. I'm glad that you're here with me today. We are going to be talking about quadratic word problems and how to interpret them and read them. So make sure you have something to write with, something to write on, and let's get started. Okay, right here. So our first problem here, we have a soccer simulator shows the flight of a soccer ball. The graph below shows the height of the ball in feet as a function of time in seconds. All right, so when we first look, we want to look at some key aspects of our graph, right? Right here, our vertex, really important. Usually our x and our y-intercept is going to be important. These are x-intercepts right here. So usually there's some key points that are like super, super critical. So here's the basic idea, is that I guess there's this guy, right? And he kicks the little soccer ball. Woo! It goes all the way up, yes? And then it goes all the way down and it hits the earth, okay? And so when we're looking at this parabola, okay, our vertex is the very tippy top, right? Sometimes it can be the very, very bottom. But in this case, it's definitely the maximum height. Okay, when it gets to this point, that's the tallest that it gets, okay? And this is, of course, our vertex, okay? Right here, go down here, this right here, because this is the x-axis, these 2 points happen to be our x-intercepts, okay? And of course, if you remember, there are 3 other names for x-intercept, right? Here we have the x-intercept, but there are 3 other names. Solution, so when they ask you to solve, they're looking for those points. 0, so they ask you for the 0, they're looking for the x-intercept. And finally, root. So keep that in mind, rocks. All 4 of these words mean the exact same thing. Here, of course, we have another x-intercept. But because it's at the origin, not only is it an x-intercept, it's also x and y-intercept. Okay, only because it touches both the x and the y axis. Go ahead and do this. Intercept. Okay, so we want to be aware on the x-axis, this is all about time in the unit of seconds. And on the y-axis, see, we can make it into y. On the y-axis, it's all about height in feet. Okay, so let's address some of this. We have our vertexes right here. I'm going to go ahead and draw a line. This right here is called my axis of symmetry, right? Axis of symmetry. I'm going to go ahead and write that in. It's my axis of symmetry. And that usually will tell us the x coordinate. And our axis of symmetry looks like it lands at about 1.5, okay? So here I'm going to make sure, notice that it's not going up by 1, right? So that's 1, 2, 3, 4. I have a difference of 20. 20 divided by 4 is 5. And so that means that this is like 25. This here is 30. And this right here is 35. That gives us an idea that this right here is probably, I say 38. 38 sounds good. Okay, so that point is going to be 1.5, 38. So this point tells us 2 things. Number 1, it tells us the time, 1.5 seconds, and it tells us the height, 38 feet. And as far as what it means in context, we can kind of put it together. It's basically the amount of time it takes to get to the maximum height. Okay, so it took 1.5 seconds to get 38 feet in the air. So from here to there took about 1.5 seconds, right? All right, next one, let's look at our x-intercepts. Now we happen to have two of them, so we'll go ahead and list both. One is at the origin, 0, 0. The other is at 3, 3, 0. Okay, notice that at your x-intercept, y is always equal to 0. And this first x-intercept is the starting point. In this case, it also happens to be also the y-intercept. I'm going to abbreviate. Okay. For this one right here, this was our starting point. This refers to the time. Make it a little darker. Sorry. The time that it takes. Time the ball takes to land. Okay, because of course, here's our height, and here's our time, right? So it took 3 seconds to go all the way from here, all the way up, and then all the way down until it hits the earth, it hits the ground, right? So here we have a height of 0, right? That's our 3, 0. Okay. Now our y-intercept in this particular example happens to be the same as our starting point. It's not always that way, but it is this time at the origin, okay, at 0, 0. I always like to think of the y-intercept as typically where you begin, typically, and this is our starting point. It also indicates the location, or in this case, the height at the starting point, okay? So it indicates the height at the starting point. A little extra T. Okay, so here in the very beginning, that's what 0 seconds means, right? In the very beginning, our height was initially at 0, right? Okay, but we didn't always so there's those basic main points, but we have some other interesting points, right? We have right here, this one point I'm going to pull at 1. So I'm going to go all the way up and take it over. And it's just a little bit short of being 35, so I'm going to say it's about 34. Okay, so I could write obviously that point as 134, or I could even write it as f of 1 equals 34. Okay, keep that in mind, right? I could have another point here. Let's say that we have 2.5. I'm going to put it about in between here, 2.5. So my input, f of 2.5, would have an output of, let's see, about right there. Gotta say, that's like the wiggliest line ever, and then we're looking over, I'm thinking like 21. That's the nice with things with graphs. You can kind of just estimate. So we have an output of 21, okay? So when we consider this right here, notice how we have x, y. So this right here, this is our x value. Here is our y value. And if anybody remembers Dixie Royd, Remember Dixie Royd? Of course you remember Dixie Royd, right? Because you have your X and your Y, and your X goes in the parentheses. That makes it input, okay? And that makes the other one output. You got your X and your Y. You got your domain and your range. Your independent and your dependent. Okay? So right here, all of these like f of 1, f of 2.5, those are all your inputs, okay? That is all referring to the amount of time. This is our input, otherwise known as our X values, as our domain. Okay, you get the idea. Our output is going to be like 34 and 21, and this refers to the height in feet. Okay, this is our output, our Y, our range. You know, so basically if I look at this, I'm like, okay, at 1 second, my soccer ball was 34 feet in the air. At 2.5 seconds, my soccer ball was 21 feet in the air, right? That's how we say that. And finally, domain and range. Well, great. Domain is all about X. So I'm going to be totally focused on the X. There's this other word, though, here, reasonable. Well, that's where we have to kind of take into sense, like, you know, there's what makes sense mathematically, and then there's what makes sense in reality, right? And so although this is a lovely parabola, if we look at this little tail right here, notice we didn't address it. Right here, this is where we would have negative seconds. Does that make sense logically? Like if we're kicking a soccer ball to have negative seconds, was he like under the ground kicking it? No. So it's not reasonable. And so I want to go ahead and eliminate that one, right? That's like not reasonable data, right? And again, he kicks the ball and it lands on the earth, right? Does it go through the earth? They didn't mention anything like that. So this right here is not reasonable. Okay, so we want to eliminate that. So when we're looking at our domain, right? When we're looking at our domain, let's go ahead and we go all the way. We're totally focused on our x-axis. I'm going to go all the way from the left to the right. Biggest from little to big, right? I got two values that I'm looking at. I've got 0 on the x-axis, and right here we're looking at 3, right? So let's go ahead and let's write that down. Domain is all about X. There were no open dots. Our little number goes on the left, 0. And our big number goes on the other side. So this is our reasonable domain, all about time. Okay, basically the whole process went from about 0 seconds to 3 seconds. With reasonable range, we're looking at all the possible heights, right? And so range is all about Y. There were not any open dots. And when I look at the graph, I'm going from the very lowest number on the y-axis all the way to the highest number on the y-axis. So here I am. Here's my lowest because it didn't go below the earth. Okay, and this is reasonable, right? And so that's 0. And then right here, my tallest, remember we had said that had a maximum of 38. Right, from 0 to 38 feet. So let me go ahead and put in those numbers. Little number on the left, 0, and the big number on the other side. And so we're looking at heights all the way from 0 feet to 38 feet. And that's how you do this one. Okay? Make sure that if you have any questions along the way, you write them down. Bring them to your teacher during sync time, okay? Let's look at one more example. And this one's a little bit different because we don't have an X and Y intercept at the origin. So Here we have a graph that represents a golf ball hit with an initial velocity of 8 meters per second from a platform 60 meters above the ground on the moon. Wow, okay, on the moon. So the height of the ball after X seconds is given by this equation. Equation looks important. I'm going to highlight it. Okay, got some other numbers, may be important. Let me highlight those. 8 meters per second. And we're looking at tossing that golf ball from 60 meters above the ground. Okay, well, that 60 meters above the ground definitely explains why we would be sitting here at the beginning of our story, right? We said the y-intercept is the beginning of our story, and why we're starting off here at 0, 60, right? So that's totally our y-intercept. That makes sense with the story. And it's also represented in the equation. Remember, the value for C is always our y-intercept. So let me kind of plug that down here. I got a y-intercept of 0 and 60. So remember, your y-intercept always has x equaling 0, right? Your x-intercept's always going to have y equaling 0, right? So let's go ahead and look at our x-intercept. All the way down, boom. And there are going to be times when it makes sense that it went through the earth. You know, maybe it's water, right? And it can go below water, right? However, this right here, even though we're on the moon, it's not going to go through the earth, right? So we have an x-intercept. So that's probably the end of our story. And we have an x-intercept at 15, 0. So I'm going to put that in there. Now let's talk about what they mean. So here, this is, again, the amount of seconds. Took 15 seconds. For the ball to hit the ground. See if I can squeeze it in there. There we go. And this one, again, is the starting height. It's our y-intercept. It's where we begin. The starting height of the ball before it is hit. Okay. Let's talk about our vertex. First of all, in this case, it is a maximum value. It is the very highest that it got, right? And it is located at 5. And we pull it over right here. We're looking at about 80, right? 580. So I'm going to write down 580. We're looking at basically the time it took. It took 5 seconds to get to 80 feet in the air, or 80 meters. I apologize. There we go. 80 meters in the air. Okay. So the vertex so often tells us how long it takes to get to the maximum, and then what is the maximum, right? So here again, we have time is x, right? And the y value is the height, and this is in meters. Okay. Let's go ahead and look at specific values, okay? So let's say that I had the point 1060. Let me make sure. Is it 1060? Yeah, right here. Boop, 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 boop. Go up and go straight across. Let me do a little contrasting color here. 10 all the way up. Take it all the way over. And ladies and gentlemen, we are at 60, right? So that point 1060 can also be written as f of 10. My input goes inside. That's x, right? And then my output is 60. Okay, so we're looking at 10 seconds. That ball was 60 meters in the air. So again, let me write that down. At 10 seconds, the ball is at 60 meters. Okay. Now, finally, we're going to talk about reasonable domain and range. So I want to look at what's not reasonable. Let's look at this little tail right here. Okay. So notice they're hitting it pretty high. It's on a platform, so it must be kind of like if you've ever been to Top Golf, right? They have you like right there very high, and you like, put the little ball and it goes like that, something like that. But does it make sense to have negative time in that sense? No, it doesn't. So that's not reasonable data right there, right? Does it go through the earth? No, it doesn't. So that's not reasonable data, okay? And so what we end up with now is our nice little concise area. And we're going to go ahead here and look at our domain. We're going to start all the way little numbers on the left. That's 0. And big numbers on the right. Biggest number right here, that's totally 15, right? So this is all about x. I'm going to put it together. X is in the middle. There were no open dots. So I have less than or equal to, and my little number goes on the left. Big number goes on the right. We're almost done. Range is all about y. There were no open dots. Let's look at our smallest value and our biggest value, okay? And so I'm going to do it in green. We got it low right here. On the y-axis, that's 0. And then I'm going to take it over here, the very top. That's 80, right? So we're going to put it in 0 and 80. That means that we had heights all the way from 0 to 80 meters, and it took between 0 and 15 seconds. All right, ladies and gentlemen, I hope you enjoyed today's lesson. Please bring any and all questions to your teacher, and I hope to see you very, very soon. Take care. Bye-bye.